Hello, how are you doing? In this lecture, I will try to cover the second chapter, the variables and basic types. This time the lecture is going to go from something quite easy to something very much complex. Okay, so I will try to skim through the basic through definitions and all those basic things because some things are really basic, like you should know them easily. That's why I will be skipping that portion and not be going that much into depth into that side. Okay, so let's start. So the this whole chapter discusses about how the language is built. It means it discusses the portions of the language. Okay, so I will explain things and then it would be much clearer to you. Okay, so first of all, we would see the primitive built-in types. Okay, the primitive built-in types. So these are the types that the user can define. So it can either be void, okay, and arithmetic types. Sorry, I said user can define. It's by definition. I don't mean that they can define. It means that user can input values into these types. Okay, so these can be of two types: void and arithmetic types. So primitive built-in types. These are what are the basic building blocks. So the void types means that it is empty, and the arithmetic types are one which store values and those things. So arithmetic types can further be classified into your integral types and the floating types. So if you have done any language, then you must be familiar that integral types, these store integer values only, and the floating types, these are able to store the decimal values also. So now we will look at the major data structures, major data types that we have in our language. These are your bool, character, integer, and float. Okay, and all the other types that are available there, they are just a variation of these basic data types. So we just need to understand these, and then we will be able to define variables easily whenever we are programmed. So first of all, we will see bool. Okay, so bool is short form for boolean. Okay, everything that has been written there, it is going to be written exactly like that whenever you are coding. Okay, so bool means boolean type. Okay, so boolean type is a type which can take a value either 0 or 1. Either it is 0 or 1. Okay, either 0 or it is going to be 1. So this type is frequently used for your true false things. Okay, so for checking whether value is true or false, boolean type is used. Regarding the size of this type, it is not defined, but since it's occupying a bit, you can say that it is 1 bit, but it's not defined because everything that we usually define is in the type in the size of bytes. Okay, so it is just occupying 1 bit. So in many books, it is written that the size of bool type is not defined. Secondly, we will come to character. Okay, so character is anything that can be typed through your keyboard. Okay, and each character takes your 8 bits of memory space, which implies it takes 1 byte of memory space. Okay, usually the size of your variables, it would vary depending upon the architecture of your processor. If it's a 32-bit system, the size is going to be different. If it's a 64-bit system, size is different. If it's 16-bit system, the size is different. So it depends on the architecture of your processor, the size of these variables. So char has 8-bit size. It is fixed on all system that character is going to have 8-bit size always. Next, you can see these variations of characters. So this is white character, cat16t and cat32t. So if you see uh, character, the char data type which was made was intended for your English language only. Okay, so it contains all the things that are available in your US keyboard, but it doesn't have more characters that are available in foreign language. For example, if you see this Hindi language or your Chinese language, then 256 characters, which is the limit of its storage, because it's taking 8 bits. Okay, so since I'm assuming that you are a bit familiar with computer science and all, so if it's taking 8 bits, then there are total 2 to the power 8 possible combinations. Okay, so 2 to the power 8 means that it's going to take 256 different combinations. Okay, so 256 different values can be stored in character. But if you see other foreign languages, then the number of characters in those languages are much higher. That's why we need WCAR, T, CAR 16T, CAR 32T. 32 CAR 32T, these have 32-bit size. This has your 16-bit size, and white character also has 16-bit size. So it's just varying in your implications. Okay, you can see more about this online, and regarding their sizes, it's not that much important. You should know about character, but okay. Character we have covered, bool we have covered. Next we go to int. Okay, so now int, again the size of int is dependent on your processor architecture. If it's 32-bit operating system, then 32-bit compiler, then the size is going to be 32-bit. Usually the compilers are 32-bit only. There are some old 16-bit compilers also available online, but usually the compilers that we are having nowadays, these are 32-bit. So 32-bit compiler, the size of int is 32-bit in a 32-bit compiler. If it is a 64-bit compiler, then the size would be 64-bit. Okay, and similarly the size of long and long, these all can be found online. You should just know that int would be able to store integral values, and your float would be able to store your decimal values, and rest of them, they are variations. Okay, float has typically 6 precision, 6 decimal precision. Double has 10 decimal precision. Long double has also 10 decimal precision. Of course, the number of values long double and double are taking, it is also increased. Okay, so regarding the size, you can find the size online. You should just know the implication. Next we come to type conversion. Okay, type conversions, I would be majorly focusing upon these two interesting things, unsigned and signed, because it is a common place of mistake. There are also type conversions in which a lower type is converted to a higher type. For example, if you can visualize it more like if there is a data type which has lower number of bits, then that data type would be converted into a data type which is having a higher number of bits. Okay, so if you have int data type, then it has lower number of bits. Okay, supposedly it's 32-bit, and then you compare it with float. Okay, float also has additional features. Okay, not just talking about bits. Float has additional features like it has a decimal point. So int would be converted to float. This is the order of your conversion. Bool would be converted to char, bool would be converted to int, bool would be converted to float in any of their operation. For example, if you have something written like this char, okay, char if you have written, and if you have something like this int b, okay, int b you have written, and if you write a plus b, then this whole expression, and if you are assigning to this to c, okay, so this whole expression, this would be evaluated as an integer. Okay, so your character, it would be converted to the ASCII value, and this b would be converted to b is int, there is a type conversion of a. Okay, so this whole becomes an integer. Okay, so I would not be focusing on this because you must be knowing this if you have familiarity with some language, as I said before. So we talk about these two interesting things, unsigned and signed. So if you see your unsigned type, most of you would be knowing it does not include your negative numbers. Okay, so if you take the example of your integers, so it is from -2 to the power 31. This power, it depends on your compiler type, 32-bit or your 64-bit, whatever it is. 2 to the power -2 to the power 31 to 2 to the power 31 minus 1. Of course, 0 is included here. That's why we are getting -1. So this is a typical signed data type. Okay. Now, if we talk about your unsigned data type, then it is from 0 to 2 to the power 32. Okay, 2 to the power 32 minus 1, 0 is included. Okay, so this is your unsigned data type. So why is this happening? It is because if you consider any sequence of your bits, then if it is an integer, okay, this continued. If it is an integer and it is signed, then the leftmost bit, it would be used to indicate whether the data type is negative or positive if it is signed. Okay, so this additional bit, it is going wasted in, not wasted, it is being used in determining whether your value is negative or positive. But if you have an unsigned type, then this bit, this is also utilized, and that's why you are getting more values, to the power 32 minus. Now we will see how unsigned and signed types behave with each other, and what precautions you should be taking. So I have written a code fragment over here. Okay, so focus on this part. Unsigned, signed. So unsigned, if you try to combine an unsigned type, unsigned data type with a signed data type is the defaulted version. Okay, so if you have written just int, then it is by default a signed data type. So if you try to combine both of this, the output that you would be getting would be unexpected. Now, why is this happening? It is because your in evaluation of u plus I, your this whole expression, it is getting promoted to unsigned data type. Okay, so this integer, this signed data type, it would be converted into an unsigned data type. Okay, so if a signed data type is converted into an unsigned data type, so see, signed data type would having a value here 0 or 1, which would be indicating whether the number is positive or negative. So 0 is what stands for positive, and your 1 is what stands for negative. Okay, so if you have something like -42 over here, so if you have something like -42, then this would be 1. Okay, and you would be having some bits over here, 1 0 whatever. So if you would try to convert this into an unsigned data type, which is what is happening, because you are trying to combine an unsigned with signed. So signed is getting promoted into your unsigned data type. So this bit is converted into your unsigned data type. Now the compiler is not taking any precaution. It is not considering this as a signed data type, so it would not consider this bit as something special. It would just use it in some evaluation. So if you see, this is the 32th bit from your beginning. Okay, so 32nd bit from the beginning. So the value you would be getting would be 1 into 2 to the power 31, and plus whatever it is left over there. Okay, whatever it is left to represent 42. So the output would be very much high, and it would be very much unexpected by you. Secondly, we would be focusing on your this for loop. Again, if you see, this is also a very commonly done mistake that we make. We declare this as unsigned, and then we are putting a condition that u must be greater than equal to 0, and then we are decrementing this. So when we decrement this, the unsigned data type, it would never become negative. So if the data type never becomes negative, then it is always greater than equal to 0. And so this loop, it would run for an infinite amount of time. So these are two interesting cases of type conversions in unsigned sign. That's why I pointed it out over here. Okay. Next, okay, I had written this also. So you need to focus more on these data types. Sometimes long is also used, but these would be the ones that you would be frequently using. Okay, double is more commonly used than float. Float is not that much used as double is used. Okay, so now we will move to your literals and assignment. So what we have covered previously, it was your variables. Okay, the data types that were defined by the compiler for declaration and definition of your variables. Next, we will move to literals. So literals are, first of all, we start with the definition of your literals. So literals are anything which is constant. Okay, so for example, if you write something like cout3, if you are writing, then this 3, it is constant. So what is this 3? This 3, in reality, it is called a literal. Okay, so there are two types of your literal, int and floating point. So integer literal, if you are just writing somewhere 3, just let me show you in a code fragment. For example, if you have written like this, int u equal to 10, then what is 10 over here? 10, this is a literal. Okay, everything that is written here has a meaning. Everything that is written in your code has a meaning. These are your comments. This is what a data type is. Okay, this is an operator. Okay, this is variable name. Okay, this is your literal. Okay, so everything that you are writing, it is not that it is anything. It has got a predefined meaning. Cout, it is your object of your OStream class. So everything that is written over here has a meaning. So u equal this 10, this is a literal. Okay, so integer and floating point literal, you should remember this thing about that, that these are not stored in your memory. Okay, so integer, floating point literal, and character literals, these are not stored in memory. But we would come to a very special case, which is string literals. Okay, so now the string literals are special in the sense that these are being stored in your memory. Okay, so if you are writing something like this char star, you must have seen at various places this type of declaration. Your char star be equal to something. Let's type hello. Okay, so this is perfectly valid. Okay, so many people get confused that how is it that we are assigning a variable value to something constant. Okay, so literal, this is a string literal, and string literal is, these are being stored in memory. Okay, so this is an important thing that you must know. Your character literals and integer and floating point literals, these would not be stored in memory. Next, coming to your character literals, we have your escape sequences. So escape sequences are something which can't be seen. Means these are like empty spaces or your beep sounds or something like that. Means these can't be typed by keyboard. The actual definition is that escape sequences can't be typed by a keyboard. Okay, so before we move on to identifiers, I would like to explain something, your prefix and suffixes. Okay, so I have not written anywhere or okay, don't worry about that. Okay, so what I would like to tell you about is prefixes. Okay, so your prefixes are something which you would put before your literals to change their meaning. Like if you are writing C out 3, then by default the compiler is assuming that 3 is an integer. Okay, it's not saying that 3 is long, or it has it is not saying that 3 is a character. It is by default assuming that 3 is your integer. Okay, so you have something called prefixes, and the other thing, suffixes for fixing up this thing. Okay, so prefixes are used for your characters, and suffixes, these are used for your floating or integral types. Okay, so prefixes, generally they are of the form, U, or L, U8. All these have got meanings. U means that your character is Unicode 16 character. This capital U means that it's Unicode 32 character. L means that it's wide character. U8 means it's UTF-8 character. Okay, so these can be assigned at the front of any character or character string literal to give them the specified meaning. Next, we move on to your suffixes. Okay, so suffixes are used for your integral and floating point types. So integral types, suffixes, I would just be giving examples. You can search about them on internet. It's not so much widely used, prefixes and suffixes, although it's used in some contexts, but it's not that much used. So you must have just a general idea about it. Okay, so that was suffixes. So you can put prefix like U, A, and it would be your Unicode 16 character. And if you put suffix like 3U, then it automatically becomes an unsigned type. Okay, so this is interesting that if you put -3U and put do C out, then this would be yielding you a different value, not -3. Okay, so this is how it is used. U, or you can also put capital U for the unsigned. Then -3L for making it long, or LL for long, and stuff like that. F for your float, and D for double. Sorry, not D. L or your capital L for long. So these can be found on the internet. Suffixes and your prefixes, you should just know about them. Before I move further to identifier, there is one more topic that is left. That is your representation of the values. If you write something like the C out 3, then this is in the form of your decimal. Okay, so I can also write it in the form of your octal or hexadecimal form. Okay, so in both these forms, the output would be 3 only. Okay, so the octal form, these begin with your 0, and hexadecimal forms, these begin with 0x. So these can also be used in replacement to your usual decimal form that you are typing. This is just, you should know this thing. You won't be obviously using octal or hexadecimal form, but it can also be used. Okay, so next we will move to identifiers. I'm not going to go into I'm not going to talk much about them because it is very much easy. Identifier is something which is a reserved keyword. So these words are reserved by the compiler, and you can't use these words anywhere. Like if you have this keyword, this identifier class, okay, so the class cannot be used as a variable. Okay, if there is your struct can't be used as a variable. So this is a basic thing you must be knowing. Next we move to initialization. Okay, so initialization, this would be something new you would be knowing. After this, it's going to become a little tough. Okay, so we move on to your initialization first. Let me see this. Okay, so uh, whenever we talk about initialization, there also comes an alternate term which is your assignment. Okay, so there is a huge difference between your initialization and assignment. Initialization, it is not assignment. Okay, if you are writing something like this int a, and then you are assigning it a equal to 3, so this is assignment. Okay, this is assignment. This is not your initialization. Okay, let me just clear this. This is not a initialization. You have you have declared the variable before, then it is automatically default initialized, and then you can't, if you just assign any value to it, then you are not directly assigning it. Okay, so there is a difference between your initialization and your assignment. Okay, so initialization, this can be broadly divided into your list initialization, default initialization, and your constructor initialization. So first of all, we would take the simplest default initialization. So if you see your default initialization, then in this case, if you just declare any variable int a, and that inside a function, okay, so it has a local scope, not a global scope. I hope you would be knowing about scope. Okay, so if you just declare int a, then the compiler will automatically feed some garbage value into a. So this is what we call a default initialization. Okay, so it is by default, the compiler is initializing a with some value, and if you use this value, if you copy this without assigning it any further, like if you copy if you define something like int b equal to a, then it's not allowed. Okay, this thing is not allowed. I don't know whether it is an error, but this is surely not allowed. Next, we go to your list initialization. So list initialization is very much popular in arrays, vectors, and your container things. But for now, we would just be seeing what it means. Okay. So if you are writing something like this, int a3. Okay, I have written a proper code. Just let me use that. Okay. So if you are writing something like this int a0, then this is what we call list initialization, and int a equal to 0, this is also a type of list initialization. Okay, and one interesting thing that you must know about list initialization is that if you are initializing like if you have some value, if you have some variable value, okay, and you are trying to initialize it into some other data type, then if there is a loss of information, then the list initialization, it would not take place. Okay, so if we have declared something like long double d ld, and then we are trying to initialize your integral values with ld, then the compiler, it would not allow, it would show an error, because this initialization does not allow uh, any losing of your information. Okay. Next, we would move to your constructor initialization. Constructor initialization, it is used like this. Okay. Constructor, you would see in classes. Some of you may be knowing about constructors already, but this is what constructor initialization looks like. So many a times, people who have studied classes, in the 11th, 12th, they feel that constructor is only limited to the classes. It's not just limited to the classes. It's limited. It has a wide scope in other data types also, like your integral data type. Here you can write int a and in parenthesis your 0, and this is also a correct way of initializing it. And if you are initializing using a constructor, then in that case you don't have to worry that you are initializing some other data type into your data type, which is losing value. Like if you are writing int c ld and d equal to ld, then in this case there would obviously be a loss of these digits after the decimal, and you would be writing this as c3. Okay, means the value that would be in your c variable, it would be 3, and in d variable it would be 3. Okay, so the value would be truncated, but this is allowed. This would not show up as an error. uh, next we move on to your separate compilation. So C++, it offers you the feature that you could you could write your code into different files, and then compile those files together to make your one whole program. So this feature is very much useful. Like if you are writing some code and you have to add functionalities to it, then you can just make separate files, and you can run those files whenever you want, instead of worrying about copying the whole code from this file to this file. It is a very neat method, and it's highly recommended that whenever you are doing some project or something like that, or even if you are studying about some algorithms, like if you are studying about graph and other things, then it is very much recommended that you make separate files about those stuff, and then compile those files together. Okay, so for separate compilation, C++ offers you the feature of declaration and definition. So you make a master file, which is your .h file. Okay, it is not necessary that this is a single file. There can be multiple .h files, but you have to include this .h file into all your CPP files. Okay, so CPP files are the files which would be compiled, not your .h file. Okay, .h file is just included, and in .h file you can put all your declarations. Okay, so you can put your declarations here, and then the definitions of your declarations can be in your CPP files. Okay, and then you can compile these CPP files together. So this is a feature of separate compilation. So let me just show you the difference between what a declaration and a definition. So here it is. Here is your declaration, extern int I. This is a declaration. Okay, if in case of external variables, you must be knowing that external variables, these are declared, but these are not defined. Okay, extern, if you write extern outside some your variable, like it could have been character, float, or anything else. So this would be declared, but this would not be defined. You have to separately define this variable, or you have you have to separately define this variable in your CPP file. But if you just write int j, then it is both a declaration and a definition of it. Okay, so and if you this is what is the definition of your pi. So you can declare the variable names in your header file, and then you can further define them in your CPP files. So declaration is important so that the compiler gets to know what variable you would be using in your CPP files. Okay, so declaration of anything in your header file is very much necessary, and it is very much recommended if you are making multiple files in your project. Okay, so this is completed. Now would be a tough part, compound types. Okay, so compound types, these are your references and pointers. Basically we would be talking about them, and then we would be going to your type aliases and auto type specifier and declare type. Okay, so these are new things, auto type and declare type in C++11. Pointers and references, many of you must be familiar, but we would be going very much into depth into these topics. Okay, so first of all we would talk about what exactly are references. So the thing you must know about references is, first of all, that they are not objects. Okay, these are not objects. They don't have their own identity or something like that. Okay, these are just referring to someone else, and you have to define your references whenever you are writing references anywhere. Then it must be defined. For example, if you write something like this in ampersand a. Okay, so this ampersand it is used to it is used to show that a is a reference. Okay, ampersand has no relation with a. A is your independent variable name. Okay, so don't confuse like ampersand a, you have to type always. No, ampersand is just showing that a is a reference. Okay, it is the purpose of ampersand is just to show that a is a reference. Okay, so if you are writing something like this directly into ampersand a, then this is an error, and this is not allowed, because it is a reference. It has no identity of its own. Okay, a does not have any identity of its own, means it cannot be initialized, and that's why it cannot be default initialized. Means a would not be given any value by your compiler. Okay, so writing something like this, it is an error. It must not be done. So whenever you are writing a reference, then it must be initialized at that point only. You can't assign references once you have initialized it. Okay, what am I saying? No, you can't assign references once you have declared them. I'm sorry about that. You can't assign references once you have declared them. Like if you have written int ampersand a, then if you are doing like a equal to something like here, then this is an error. Okay, first of all, this is not only allowed. So when the compiler will reach this line, then it would directly flash off an error. So we have talked about this. Secondly, if once a reference has been binded to an object, like if you have written int ampersand a equal to b, where b is your some other integer like int b. Int b you have defined declared somewhere else, and you have initialized it. So if you have binded a with b, then the reference cannot be unbinded. Okay, a would always be referring throughout your program. Wherever it has scope, it would be referring to b always. Okay, so whatever changes you make in a, these would be reflected in b. We can also say that a is your alias name for B. Okay, so if you write A equal to 1, then it would be reflected in B. Okay, so it would be reflected in your object. And thirdly, your single object, it can have multiple references. Like we have B, so we can also write int ampersand C equal to B. Okay, so B is having multiple references. Okay, C, it is allowed that A is also a reference, C is also a reference of your same object B. And lastly, this is very much important, that reference to references can't be set up. Okay, so if you are writing something like int ampersand D equal to your A, okay, whatever, int ampersand D, whatever. In pointers we usually write star star, but this is not allowed, so I'm just guessing what it could have been. So this is not allowed. Okay, so int ampersand D or whatever there is, you can't set references to reference because they don't have any identity of their own. Okay, they are not occupying any memory, they are just a name of your object. Okay, so you can't just set a reference to this reference. Okay, we have completed with this. Now we would be moving to your pointers. So pointers, let me just see if I have written any example over here about references. Okay, so here you can see int ampersand ref val 2. It is an error because it has not been initialized. Okay, int ampersand ref val equal to ival. It refers to ival. Wherever you would write ref val, the changes, they would be reflecting in your ival. Okay, next we would move on to your pointers. So first of all, we will talk about pointer value. So what all values can a pointer take? So a pointer, it can point to an object. Okay, it can point to a location just immediately before the object, or it can point to a null pointer, or it can be invalid if it points to any of the previous three values that I have said. Okay, so basically three things it is being able to point. It can point to an object. Okay, it can point your past an object, or your just after the end of object. Okay, so this concept, it would be very much useful in your iterators. We would be discussing iterators afterwards. It would be very much useful there. And thirdly, it can be a null pointer. Okay, it can be a null pointer, and if it is not any three of this, then it is invalid. Okay, you must remember, this is a rule. If it is not pointing to an object, if it is not pointing after an object, or after the end of an object, or just past the object, or either it is not a null pointer, then it is an invalid pointer. Okay, so we would be going into detail about null pointer. So we will be seeing null pointer now. So let me just give you first an example how you will initialize your null pointer. So these can be initialized in three ways. In by writing your null pointer, or you can write a 0 in place of null pointer, or you can write null. Okay, so null pointer, it means that if you are initializing any pointer with null pointer, it means that it is pointing to no value. Okay, then you have your this pointer, if you are initializing it to 0, it also implies that the p2 pointer, it is not pointing to anywhere. And thirdly, if you are initializing it to null, it also implies that p3 is pointing to nowhere. Okay. And if you are using the keyword null, then you must include cstd lib file. So what exactly is the importance of your null pointer over here? So why null pointers are so much used? First of all, I would like to tell something about pointer, and specifically about their size. Okay, so I would be talking about your variable pointer, not function pointer. Function pointer we would be discussing afterwards. First, let me just focus on your variable pointer. So in case of variable pointers, the size of all the pointers by default is same. Okay, so it depends on, again, the architecture of your processor. If it's a not architecture, the compiler type. Okay, if it's a 32-bit compiler, then by default the value of the pointer, it is going to be your 32-bit. If it's a 64-bit compiler, then by default the value of your pointer, it is going to be 64-bit. And it does not matter whether you are declaring your integral pointer or a floating type pointer or a character pointer. So the size would always be the same. Okay, and it would just be dependent on your compiler type. So if you are declaring a null pointer, then you can make it point to null, and then you can declare. Okay, sorry, I'm really sorry about this. I was not talking about null pointer. Okay, so this you have to remember that your 32-bit and 64-bit, this is important. Okay, so 32-bit pointer and 64-bit pointer, this is what is important. The size, it is important. Okay, so null pointer is just a pointer which is pointing to null. Okay, and null pointer, it can later be initialized. For example, if you are just declaring something like this int star p, okay, then this is very much harmful for your computer. Why? Because if you are not initializing any pointer, and if you are not even initializing it to null value, then in this case the compiler would would declare a garbage value to this pointer. Okay, so if it's declaring a garbage value, then p is having any arbitrary memory address, and if p is having any arbitrary memory address, then if you accidentally used p pointer anywhere, okay, then you would be directly manipulating that memory address. For example, if you have not declared anything, then the compiler would default initialize this pointer, and it would point to just any arbitrary memory address. And then if you would be using your p pointer, then the values, they can be manipulated, and you would be getting unexpected outputs. Okay, so null pointer is important in that regard, that you have to declare it as null if you are not immediately using it. Okay, either you can initialize it like either you can initialize it like int star p2 equal to something. It's not written over there, but you must be knowing about initialization if you have done C before. So that is not something to worry about. So int star p equal to p1 if I have written, and p1 it is some value, then it is manipulating this value on. Okay, so this is an initialization. Or the second form of initialization can be if you are pointing to a null value. So if you are pointing to a null pointer, so if you are not initializing it, then you should make it point to a null pointer. Okay, int star p equal to null, you should do this. Okay, otherwise you would be getting unexpected outputs, as p would be pointing to any arbitrary name. Next we would move to your void pointers. Okay, so void pointers are very much special, and everything that I have talked about size, it would be very much valid in that case. Okay, so depending, all the pointers have the same size, not that thing. That's why if you are declaring a void star pointer, so this is a pointer which does not have any type. Okay, whatever pointer you were declaring till now, like if you are declaring int star something, int star p, then p was having some your value, sorry, not value, data type. But if you are declaring something like void star, then what data type does it have? Void is an empty data type. Void does not have any meaning. Okay, so in this case, what happens, why is this useful, is because you can assign this pointer to any type of point. Like if you have declared say int star p1, and you declare not declare, if you have initialized int star p1 to some value, consider a. Okay, if you have initialized it to a, and then you are declaring a void star pointer, and then you can assign this pointer directly to this pointer. So p equal to p1, it can readily be written. Okay, uh, but if it would have been a float star pointer, if would have been float star p, then if you would write p equal to p1, immediately it would flash an error. Okay, so void star pointer, it can be converted into any pointer. And why is this happening is because your all pointer types have the same size. Okay, so since they have the same size, they are just differing by your type. Okay, so if you have a void star pointer, then it is also having the same size, and it can easily be converted into your other data type. So we have talked about your void star pointer. uh, okay, so also void star pointer, these can be compared also to any other pointer. Okay, these can be assigned to any other, from any other pointer, and these can also be compared to any other pointer. And these pointers, these can also be passed or returned from any function. Now I would like to focus on a commonly confused thing, this int star p and your int star p. So in while you are declaring pointer or initializing whatever, then in this case the space, it is not important. So if you are writing int star and then a space p, and int star and p, then these both are valid things. Okay, these are both same things. It is nothing to be confused about. Okay, so if and you must also keep in mind that int star p, int star, this is not any kind of data type. Okay, star is just used to show that p is a pointer. Okay, it's not used for anything else. Once you have written star p, once you have done this int star p, then p is a pointer in its own right. And whenever you would be writing star p, like if you are writing the star p somewhere, see out, not see out star p, like you are assigning some value, you can write see out star p also, star p equal to 8 if you are writing something. Okay, then in this case, star p, it means a reference to the thing that the pointer is pointing to. Okay, so this becomes a reference in that case. So one more thing about reference that I wanted to discuss is that reference can both be an R value and an L value. So what is R value and an L value? For example, if you are saying this pi equal to 0. Okay, so this is the left hand side of the expression, and this is your right hand side of the expression. Okay, so if it would have been your any ordinary ordinary variable, then not ordinary variable. If it would have been a constant, okay, so it would have been just leave it. I will talk about it later. Okay, so next we move to your reference to pointer. Reference to pointer. Okay, so a pointer, it is, as I said, reference is not an object in its own right, but a pointer is an object in its own right. Okay, so you should be knowing this thing, that pointer is an object in its own right. If you are writing something like this, int star p1 equal to a, then p1 is, it is an object in its own right. It has an existence, it has an identity, it is occupying some fixed space in your memory, so it is an object in its own right. And a reference can be set up to any object. Okay, so that's why you can have a reference to a pointer. And now the question is how you would be having a reference to a pointer. So this thing is very much interesting. So see this code fragment here. So this is your pointer. Okay, sorry, star p. Okay, this is your pointer to an integer, and this is how you would be setting up a reference to a pointer p. So how you would be reading this code fragment would be from your right to left. Whenever you are confused about a code fragment, then you should always try to read it from your right to left or inside to out, in case of arrays or those things. So in this case, as you read it from right, then you would get to know that R is a reference type, because you have written ampersand over it. Okay, so R is a reference type, and then R is a reference type, and what is it referring to? It is referring to your pointer, which is of a type integer. Okay, so you are having a reference to something which is an integer pointer. Okay, so this is how you would read this code fragment. So then you are writing R equal to ampersand type. Okay, so in this case you have set up a reference to your integer pointer. So since a reference to an integer pointer has been set up, then that's why you can use R in place of p now anywhere. Okay, so you can write now R equal to ampersand I over here directly. Okay, so this is how it happens. And if you dereference this, okay, so R is imitating p. Okay, so if you dereference it, then it would lead a reference to your original variable I. Okay, so the way you can understand a reference is that it is just an alternative name. Okay, it is just an alternative name that you are giving to any object. So it is an alternative name that you are giving to p. Okay, so next we are done with this. Now after this we move on to your reference to constant. Where is the mouse? Sorry, reference to constant. Okay, so this is also very much interesting, and this is a bit complex. Okay, so we would be seeing examples in regards to this thing. So if you have, okay, so since any constant type, it also declares an object, then you can have, that's why you can have a reference to your constants. Okay, so in this case, if you are declaring a constant, then you can have a reference for this constant object. Okay. And if and it is very much important to write constant over here. Okay. So this implies, again, you read the definition from right to left. So you are having a variable of a variable name r1. Okay. And ampersand means it's a reference type, and then it is having a type of constant integer. Okay, so r1 is a reference. R1 is a reference to your constant integer, and the constant integer has your value c1 equal to 102. Now, if you try to modify the value ahead, like if you try to write r1 equal to 42, then in this case it would yield an error. Okay, and again, if you try to assign r2 r2 which is not a reference to a constant, then in this case also it is going to have an error. Okay, so this thing must be remembered, that if you have some constant object, okay, constant is your boss, constant is at higher level than non-constant object. So this thing must be remembered, that constant is at higher level than non-constant object. So you can assign, okay, so you can assign a non-constant value to a constant object, but it's not vice versa. Like if you have a non-constant variable, then you can't assign a constant variable to it. Okay, constant is at a higher level than your non-constant thing. So non-constant, it can be converted into constant, but constant variable it cannot be converted into non-constant variable. Okay, so we were seeing reference to your constant. So this is not allowed. This is something. Okay, next we move on to your initialization and reference to constant. Okay, so any type of reference can be any type of reference to constant can be binded to your constant value, your literal value, or a more general expression. Okay, so we would again be seeing examples regarding this. So here are the examples. We have this integer int I equal to 42, and then we have written constant I ampersand I r1 equal to I. Okay, so since r1 is a reference to a constant, okay, and as I said, constant is at a higher level. Okay, so you can bind your I value to reference to a constant. So, but it's not vice versa, that if you have a constant integer and then you are trying to bind your reference to constant, your plain reference to it, then it won't happen. So you can bind this over here, and then if you can also write it in constant int ampersand r2 equal to 42. Okay, because 42, it is a literal, it is also something constant. So constant, it can be bounded to your literal. Okay, next we move on to your constant ampersand r3 equal to r1 into 2. So r1 is your constant value, 2 is also constant value, so r1 into 2, it can be bounded. Okay, after this we see this int ampersand r4 equal to r into 2. So in this case, r, it refers to your r1, r2, r3. So these are all your constant types. Okay, and 2 is also constant type. So this whole value, it is a constant type. R into 2, it is a constant type. It can be treated like a literal also. Okay, so in this case, r4, it won't be able to bind with your right hand side, because this whole is a constant value. Next we would there is a special example where we will see what happens if we bind a reference to an object of a different type. So there is your dval object, okay, and we are binding it to a reference which is of a different type. So how the compiler will process this one? So first of all, it would create a temporary object which would be having a value dval, okay. So this temporary constant int object, it would having a value dval, and then your ri variable, it would be assigned to this temporary object, okay. So during so this is the processing part which is actually happening, okay. So uh, a temporary object is being created, and then RIA, the reference RIA, it is being assigned to this temporary object. So if for example, if this reference, it would not be in a reference to a constant. Since it is a reference to a constant, then it would be an error if you assign Ri any value, because it is referring to a value which is a constant, okay. So if it wouldn't have been a reference to a constant, then in that case, uh, if you would have assigned a value to Ri, then the assignment would have been then done to temp, not Ri. Okay, so this is a thing to note, that if you are assigning a reference to a data type which has a different value, okay, then you would get an error, okay. Error not in the sense that the compiler would report it, but whatever you would be expecting, like you would be expecting Ri to work in place of dval, then it's not going to happen. Ri would produce a value. Ri would take a value, but it would assign it to some temporary object, and it would not be assigned to dval, okay. So this was a thing which was important. Next, after this we come to your pointers and constants, okay. So this is also a very much interesting part. So a pointer, it can be used to point to your both constant and non-constant objects, okay. So if your pointer is pointing to some constant object, then in that case your your code would be a bit different from what you have been doing directly. For example, if you write something like this, and for a normal object which is not constant, you can write directly in star p equal to a, okay, where a is int a, okay. So this is something which is allowed, okay. But what happens if a is not your integer? I mean, not a constant, not a non-constant integer. Means a has a constant value. So if it is something like constant a, then you can't use this code again, okay. This code would produce an error. So in that case, you have to assign a pointer to a constant integer, okay. So it's a constant integer pointer in that case, okay. So again, uh, let me show you a code over here, okay. So you can see here const double pi equal to 3.14, okay. Then I have made a double star pointer equal to ampersand pi. So in this case, this would lead to an error. This is something which is not allowed. You can write const double star c pointer equal to ampersand pi. So this is what is the correct code. Okay, so why this is happening, uh, we will again read from your right to left. So first of all we have the variable name. Okay, then star indicates that this is a pointer, and then const double, this indicates that this pointer is pointing to a data type which is a constant data type of double type. Okay, so that's why it is this was being assigned to your pi. Okay, so c pointer, it can now point to pi. And now since c pi is a constant, so if you are writing star c pointer equal to 42, then in this case this star c pointer, it is, you are dereferencing this pointer. And so in this case you can't just go on assigning star c pointer equal to 42 again, because this is a reference, and you can't a reference to a constant. Okay, so if you are writing star c pointer, then you indirectly indicate pi. Okay, and pi is, since it is a constant, so if you are assigning it again, then it is naturally an error. Next, after this we move to okay, sorry, pointers and constant. Okay, so let me just see one thing first of all. mm, Next we have your constant pointers. Okay, the constant pointer, it is again an interesting thing. If you there is a difference between these two terms, pointer to constant. Okay, and your constant pointer. Okay, so these two terms, these are radically different. Okay, so sorry about that. So if you just write pointer to if you have pointer to constant, then it implies that it is a pointer which is pointing to a variable which has a constant value. And if you have a constant pointer, then it implies that you have a pointer which would always point to a single variable. Okay, so this the value of this pointer, it can't be changed further once you have assigned it. Okay, so we would be seeing examples in this regard. Uh, so first of all, we have this variable and a number equal to 0, and then we write int star const square equal to ampersand or number. So in this case, we have defined a pointer. Okay, a constant pointer which would always be pointing to your this variable or no. Okay, so the way to do it is again to read from your right to left. So we have variable name, and then we know this variable is a constant type. Okay, and then we get to know this is a pointer. So what it means is this variable, it is a constant pointer. Okay, and then we see the data type. So the data type is integer. So it is a constant pointer to an integer. Okay, so we can have a constant pointer which is a pointer to a constant. Okay, so this is an example of a pointer which is a constant pointer to a constant object. This is a constant object. Okay, so now we have seen your constant pointer concept and your pointer to constant concept. So we would be discussing upon this top level and your low level constants. Okay, so this is a very interesting thing. So what we mean by top level is, top level constant means that it indicates that the object is itself a constant object. Okay, so a pointer, it is an object in its own right. Okay, so a reference is not an object, but if you write something like int star p, okay, so p has its own identity. Okay, it occupies memory, so it is an object. Okay, so top level means that this object uh, this object is itself being referred to. Okay, and when we talk about low level, we mean the object to which it is referring. Okay, so top level means the object itself, and low level means the object to which this thing is referring. Okay, so whenever we would be talking about top level constant. Okay, so if we would be talking about top level constant, then in that case it would be a constant pointer. Okay, this is constant pointer it is. And when we would be talking about low level constant, okay, uh, not a constant pointer, we would be dealing with the constantness of the pointer. Okay, not the constantness of the object to which it is pointing, but the constantness of the pointer itself. And when we would be talking about low level, then we would be dealing about the constantness of the pointer of the object to which the pointer is pointed. So you can think it as a constant pointer and pointer to constant also. That top level roughly relates to a constant pointer, and low level relates to a pointer to constant. Okay, so you would be seeing some examples regarding this. So this is an extensive thing, and it is very much confused with. So first of all, we will see this thing. So int I equal to 0. So we write int star const p1 equal to ampersand. So this and another thing I forgot to mention that it is that whenever you are assigning a top level constant, whenever you are copying an object into another, then in that case your top level constant, it is the one which is ignored. Okay, so we would be seeing examples regarding this which will explain it much more better. So if you have something like this, int I equal to 0 and int star const p1 equal to ampersand I. So in this case we have your top level constant. Okay, so this pointer is having a top level constant, and its value has been assigned. Okay, next we see this constant ci equal to 42. Okay, then in this case also I'm just explaining what is top level constant over here. Okay, so in this case if you see p1, it is related, this constantness, it is related to the object itself. It is related to your p1 object. Okay, and in this case in case of constant ci equal to 42, in this case the constantness, this is related to this object only. Okay, so this is a top level constant in this case. Okay, constant ci equal constant, it is a top level constant, and in this case this is the top level constant. Okay, you would not say this is a low level constant. Okay, because it is directly affecting, it is directly related to this object itself. After this we see this example, constant star p2 equal to ampersand ci. So in this case it is a low level constant, and ci it is being assigned to the ci. Okay, so next we see this example. Okay, so p3, this indicates your top level constant, and this indicates your low level constant. After this we see the special case of references. So as I said before also, a reference, it has no identity of itself. So in this case this constant value, it can't refer to this variable name, because this is not an object in its own right. It has no identity of itself. So this naturally that's why is a low level constant. And whenever we would be talking about reference to constant, then they would be it would automatically imply that they are low level constants, because the reference is not an object in its own right. So uh, the case where we would be having any top level constant for a reference, it would never exist. Okay, so now we see some example of copying, okay, about which I was talking, that top level constant can be ignored, but low level constants, these can't be ignored while copying. So if you write I equal to ci, okay, so we have I here and we have ci here. So this is a very normal case. Okay, so this is a variable, and this can be directly assigned. Okay, it has nothing special to it. We can see this as this like this, that ci, when you are writing I equal to ci, then in that case ci is copying its value over here. Okay, because it is just the variable is being called, and I is assigned that value. Next we have p2 equal to p3. Okay, p2 equal to, and in this case also the top level constant of this object, it is being ignored. Okay, next we have p2 equal to p3. p2 equal to p3, so we have p2 here, and you have p3 here. Where is p3? Okay, we have p3 here. Okay, so in this case also p2 equal to p3, the top level constant is ignored. Okay, so the top level constant of p3 is const, this thing. Okay, so this is ignored, and when we are writing p2 equal to p3, so this assignment is valid according to the compiler. After this we move towards here. Okay, so we have int star p equal to p3. So here it is p3. So in this case even if we ignore the top level constant, then in that case the low level constant, they differ. Okay, this is constant and this is just a plain int, so the assignment, it is invalid according to the compiler. After this we have p2 equal to p3. Okay, so we have your p2 here and p3 over here. So if we ignore the top level constant, then the low level constant, they are the same, so the assignment is perfectly valid. After this we have your p2 equal to ampersand I. p2 equal to ampersand I. So in this case also, if you see, as I told you before, that your constant, okay, where has it gone? Okay, so your constant, it is at a higher level. Okay, if you have a constant object and if you have a non-constant object, then constant object is at a higher level. Any non-constant object, it can be converted to your constant object, but a constant object, it would never be converted to your non-constant object. So sorry, so in this case, if we write p2 equal to ampersand I, so it is perfectly valid, because your int star, it is being converted to your constant star. Okay, so copying a value which is converting your non-constant type into a constant type is possible, but it's not vice versa. Okay, so you can convert a non-constant to a constant type, but not a constant type to a non-constant type. So this declaration, it is also perfectly valid. After this we see your int ampersand r equal to ci. Okay, so int ampersand r equal to ci, so we have your constant ci here, and we are just using a plain type over here. Okay, so a plain type, it can't be used to bind to your a constant type. Okay, so it's not that a constant type would get converted to a non-constant type. Okay, so we don't have a demotion over here. Okay, A non-constant type, it can be converted to a constant type, but a constant type, it would never be converted to your non-constant type. Okay. After this, if you see this constant ampersand r2 equal to y, then again your plain integer, it can be converted into can be binded to a constant type, but uh, like I said, there can be a promotion from non-constant type to constant type. Okay, so that's why this is that. After this, we are done with this. We move to type aliases. Okay, so type aliases, many of you would have heard it if you have done like C++ in your schools. Then type aliases, usually what we are taught are these types of type def, char, and then something you write. This is a more complex example, but it's usually something like type def and your whatever you have your data type and then your name, alias name that you would like to give to that data type, suppose it. Okay, or you can say number. Okay, so this is a type alias. Okay, so we would see about that over. So type aliases, these can be defined in a new way in C++11 by this term using the alias name, whatever that is, equal to your variable name. Okay, so this is perfectly valid. Now you can use no anywhere to write your variable name instead of it. Like you can write no a equal to 1. Okay, so it works exactly similar to your type def, but it is a more easier way to remember, and that's why using has been introduced in C++11. Type def is also perfectly valid. It's not that type def can't be used. Okay, so next, after this, we would be talking about some pointer and constant, which can be used in an intelligent way to clean up, need in your code more. Okay, so pointer, constant, you can use them as type alias. So let me just give an example over here. So type def, you have written type def char star p string. Okay, so again we would read it from left to right. So it indicates that p string is a pointer which is of a type char. Okay, so anywhere now you can use p string to denote a pointer to a character. Okay, so a pointer to a character, it is very much used in older versions. It should not be used. String is used in the newer versions, but many people they use, like, they write char star p equal to some your string abc whatever, to store the string value without having to write the size of p. So this was very much used in the older versions. So you can use a type alias instead of just using char star again. So now you have defined p string as a character point. Okay, and one thing you should note is that whenever now you would be declaring this as constant, then in that case that would be directly applying to this pointer. Okay, so it would be it would apply to pointer. Okay, not it is not that you are referring to pointer to a constant. Okay, it's not a pointer to a constant. Okay, many people will just do this, that they will replace char star with p string with char star. Okay, so this is a mistake. This is a wrong interpretation of this. Okay, so the correct interpretation is that p string is a pointer. Okay, p string is now a character pointer, and it can be used to define variables instead of uh, using your char star. Okay, so whenever you would write const ahead of this, then it would in that case it would imply that the pointer itself is a constant. Okay, next we have this example, const p string star ps. So in this case we have your star ps. So this implies, again reading it from right to left, then this implies this is the variable name, and this implies this is a pointer, and this is a pointer to what? This is a pointer to a constant pointer to a character. Okay, ps is a pointer to a constant pointer to a character. Okay, so if you just write your string names, use the pointer to refer to string names in the old ways, then you can make a pointer to that pointer. Okay, so I will discuss this after this. Okay, a lot of this is left. Okay, then we move on to your auto type specifier. So auto type specifier, this is also a new feature which has been added to a C++11. In your auto type specifier, it can be used by the compiler to guess the data type without the user need to explicitly specify it. Like you can directly write auto a equal to 4. Okay, and the compiler would automatically know that this is a int type. Okay, so we have complications in these cases, compound types and your constant type. Okay, so let us see this. Const int ci equal to I. We would see examples for this. So constant ci equal to I and ampersand cr equal to I, ci. Okay, so you have declared a variable which is of constant integer type, and you have declared a reference to a constant integer. Okay, now you are writing auto b equal to ci. Okay, so you are asking the compiler what is you are expecting the compiler to guess the type of b if by seeing the type of ci. Okay, so in this case, this thing must be remembered, that whenever auto type is being used, then it would automatically drop your top level constant. Okay, so your const would be dropped because this is a top level constant. Okay, so b would be an integer type. Okay, so another way to understand this is also that if you are just writing ci, then you are just showing just writing the value over it. Okay, so if I just give you a value 4 and I ask you what is it, so you would automatically say that it is an integer. Okay, you don't know it is a constant integer or what, you just know that it is an integer. So the top level constant is, that's why being dropped. Next we go to your auto c equal to cr. So in this case, again c is an integer as cr is an alias name for ci. After this we see auto d equal to your ampersand type. So we have written here ampersand I. So in this case, this is uh, your reference of the variable. Okay, so ampersand I is the reference of I. So the only object the only type which can store a reference is your pointer. So D would be a pointer of type int star. Okay. So next we see auto e equal to ampersand ci. So now in this case, uh, the the type of variable e is going to be is of constant star, because now the const in this case uh, of your object, it is a low level constant star. It is a low level constant. Okay. So if you see this reference, okay, so references are always your low level constant. Okay. If we have a reference, if we write a reference to a constant, then the constant in that reference, it is always a low level constant. Okay. So if we are having a reference over here, then this constant, this automatically becomes a low level constant. So since this is a low level constant, it won't be dropped, and that's why e, it is going to have this value constant. Okay. uh, so if you want to put a top level constant over your object, then you have to do it explicitly. Okay. The type would be deduced by the compiler, and then you have to put the const value over it. After this, we have done this. Next, we have your, okay, let me just see this. Okay, so these things are also there. If you can write auto ampersand g equal to ci, so you are binding a reference to your integer type. Okay. Then we have auto ampersand h equal to 42. So in this case, this would be error, because a plain reference, it can't be just binded to a literal type. This has to be a constant type. So we would uh, put a constant over here, const auto ampersand j equal to 42, and then in this case it would be correct. Okay. So after this, we move on to your declare type. So declare type is also a new feature which has been introduced, and it is very much useful if you have some expression and you just want to uh, guess the value out of that expression. For example, if you have somewhere written a plus 4, okay, you just have this expression and you want to you don't know what the data type is, then you can just use declare type over it. Okay. So you just write declare type, and then your variable name, whatever it is, b, and then this variable, it would be having the data type of this expression. Okay. So we will see examples regarding this. So first of all, okay, I have not easy examples over here. So if suppose this is a float type. Okay. Float type, then a float plus an integer, it would get converted to a float. So declare type would report a float type. Okay. So b would be having a float type. So declare type is very much useful if you have some expression and you want to tell the data type of your variable by using that expression. Okay. So we would be seeing its implication on references, which is a bit tough. Okay. So if we have int I equal to 42 and star p equal to ampersand I and ampersand r equal to I, then in this case, if you write declare type r plus 0, okay, so what is r? R is an integer, and r plus 0, this would compute to an integer. so B would have an integer type. Okay. Next we have your declare type star PC. So this would be an error. Okay. Why is this an error? It is because if you dereference a pointer, then you would get a reference. Okay. And reference, they must be initial. And if you are not initializing a reference, then in that case it is an error. Okay, so the data type that is extracted out of here, it is int ampersand. And one more interesting thing about declare type is that if you are using double parentheses, okay, so if you are writing something like this is a double parenthesis, then in that case the value which is returned, it is automatically a reference. Okay, so even if it should have been an int, but since you have written double parentheses, then what you would be getting, it would be int ampersand. Okay, so I have discussed declare type also. So now we are almost completed with this thing, and I have intentionally left out some things, like I have not discussed your const expression. I would be doing it later sometime when it would become more required. And then I have not also discussed your macros. Okay, so you can read about macros, if and def, and those things, hash and def. It is very much easy thing. It's not as much complicated as the pointers part was. That's why I left it out. And also you would be finding something related to classes. I don't exactly remember. So you should just look those things on your own. And I have intentionally skipped the first chapter, so you should cover that because it's very much simple. We just have your if for if type sorry if statements, and for loop and while loop and do while loop. So that's why I didn't cover that part. So thank you for watching, and meet you in the next one.